Hey guys, I'm Cyborg Sheep, and welcome to the Weekend Post. In this video, I have an upcoming project where I'm going to be using some LEDs similar to the one I have here. These LEDs are amazing little devices, but the way you power them is a little bit more complicated than you might think. So in this video, I'm going to be getting into how you power these LEDs so that they work correctly, and how we will be powering the LEDs in my project. So we start out here with a drawing. This is the symbol we would normally use for an LED when we put it in a drawing. Basically, just an arrow pointing in a direction with a line on its end and two arrows pointing away from it. And right off the bat, this drawing tells us two major characteristics of an LED. The first thing that this drawing tells us is that this component emits light, which is relatively obvious since it's right in the name, light emitting diode. The second thing that this drawing tells us is that this component will only allow electricity to flow in one direction. It will not allow electricity to flow in the other direction. An example of this right here is, you can see right now, the red and black are such as they are, and the light is on. However, if I take the red and black off, and I instead put the red on this side, like so, and I put the black on this side, you can see the light is not on. But if I reverse it again, as you can see, light is back on. It's a bit easier to grasp this concept if you think about this system in terms of water instead of electricity. In a water system, this component is more similar to a one-way check valve. So a one-way check valve, it would let water go through the valve in one direction, but it would not let water backflow through the valve. The mechanism would close up and stop the water from flowing through it. And as I just demonstrated in this case, for electricity, it's no different. Now, of course, that is not the whole story. In fact, far from it. You can see here, I have this little component here, and we'll get into why we need that right now. Getting back to our water analogy here, with the one-way check valve, when it lets water through, it doesn't resist the flow in any way. So, as I've said before, it's the exact same for this. The light itself does not resist the flow in any way. So, that has some interesting implications, so let's get into that. So in a direct current circuit, like the one we have for the LED, the resistance of the circuit is measured in a value called ohms. Now in the formula coincidentally called Ohm's Law, it tells us that the current in the circuit, or the part of the amount of power that it's taking, basically, is directly proportional to the voltage. However, it's inversely proportional to the amount of ohms, or the amount of resistance. Putting this little formula here into context, let's say, for example, that we have 12 volts in our circuit. So, say this power supply right here, it's got 12 volts coming out right there. Let's also say, for example, that we have, say, 1 ohm of resistance in the circuit. That's going to net us a value of 12 amps, which, is nothing crazy. You can get that easily out of one of these little two-prong receptacles right there. So, nothing too crazy. Let's say, for example, we have half an ohm right there. You're going to get 24 amps out of that circuit, which is a little bit more power. That's a little bit similar more to like a clothes dryer, say for example, at 240 volts, but that's besides the point. But let's go even bigger. Let's say we have 1/10 of an ohm right there. Well, in that case, you're getting 120 amps out of that sucker, and boy, this little LED right there, that sucker's done for. The thing about LEDs is that they're only designed to carry 2.5 to 3 volts at around 20 milliamps. Really, anything more than that, and the LED burns out instantly because it can't handle the high current caused by the incorrect voltage and the low resistance of the LED. So since the LED can't limit the amount of current it's taking by itself, we need a device that can limit the amount of current it is taking. One method of doing this is to put a resistor in the system, so that the current flowing through the LED will also flow through the resistor. In this case, I'm using a 100 ohm resistor. And by adding the resistor to the system in this manner, we add resistance to the otherwise low resistance of the LED. And after having run the numbers, we get a current flow of roughly 30 milliamps, which is a little on the high side, but as you can see, the system works! So rock on! Hook up all your LEDs with resistors, right? Well, no.
Using a resistor like this is not a perfect solution. That is because resistors act basically like tiny space heaters. They take the excess power that would otherwise kill the LED and convert it into heat. I mean, come on, you want lights that brighten up your living space. Not this garbage that gets all hot and bothered even with low power going through it. It being worthy of note, of course, that this effect gets even worse when there's more power flowing.
So generally, this arrangement is only used on low voltage, low power systems.
But for larger systems, like for example this chunky light bulb, we need something beefier that can deliver more power. So here's something beefier that can deliver more power.
These are constant current LED driver modules. Now the way these things work is a bit complicated, but this brings us to the second method of powering LEDs, which is to use a switched mode power supply.
These LED driver modules are similar in function to a light switch. The main difference being that the LED driver module has a bigger brain than the light switch does. The other major detail about these modules is that they use a constant current to drive the LEDs. What that means is that the voltage coming out of the module will be somewhat inconsistent. The module does this intentionally, though, to keep the current constant, no matter what load is attached.
Alright, so by connecting the red and black wire to the power supply's 12 volts and ground, hooking the I don't know if you can see there, but the yellow and gray wires, yellow going to one of the outer pins and the wiper contact, which is the middle pin, to the yellow wire, and connecting the other outer pin to the gray wire. And by hooking the blue wire to LED negative and the white wire to LED positive, this should in theory work. So let's test it out. Alright, I'd like to say I have more confidence in my work, but I guess we're just gonna have to try it. So I guess, what do you figure? Pop, fart, let smoke out. Eeeeee. Click. Okay, the LED. Where is it? Oh, okay, you know what? Here, what if I... It's working! Kablamo! These LED drivers achieve worlds difference in terms of energy efficiency, because instead of just turning the excess power into heat, they just turn the circuit off, and then they turn it on and off fast enough so that our eyes can't see it. And also there would probably be some filtering components in here to take that out, but that's besides the point. Anyways, so with that, guys, that should be everything. I'm so excited to see if this project is actually going to work. I can't wait to get started building and trying things out, and I hope you are too. So I'm going to leave the video with that, and I'll see you guys in the next episode.